Hello, welcome to another Ginger Mathematician video where we're going to go through all the IB questions we can find on sequences. I have a special guest on the video today, Margaret Maths, and she is going to go through a lot of the analysis and approaches questions, while I'm going to focus on the applications and interpretations questions. So this will get you really up to speed on all things you need IB for sequences, and we're going to get started straight away.
Hi everyone, I'm Ajita and I'll be walking you through analysis and approaches questions. Let's get started. So our first question is, consider an arithmetic sequence where U8 is equal to S8 is equal to 8, and we have to find the first term and the common difference D. So we know that the nth term of any arithmetic series is given as Un is equal to U1 plus n minus 1 times D. So using that formula, we can say U8 is equal to U1 plus 8 minus 1, which would be 7 times D. So 8 is equal to U1 plus 7D, and this could be your equation 1. If you're looking for a good introduction to arithmetic sequences, do check out the video in the description of this video to learn about arithmetic sequences and get introduced to them. Now let's move ahead with the question. So the next part of the question would be the sum of 8 terms, S8, and this can be given as the formula n by 2 times 2u1 plus n minus 1 times d. So over here, S8 is given as 8, n value is 8, so this would be 8 by 2. And then we would have 2u1 plus 7d. And this could be our second equation. Now, if you notice, we can substitute the value of u1 plus 7d over here. So we can write it as 8 is equal to 4 times of u1 plus 8. Now, when I expand this bracket, I can write this as 8 is equal to 4u1 plus 32, or I can take 30 to the other side. It would be minus 24 is equal to 4u1. So u1 is equal to minus 24 by 4, which would be negative 6. And now I can put the value back in my first equation and get the value of d. So that would be 8 is equal to minus 6 plus 7d. So this can be 14 is equal to 7d, and my d value would be equal to 2. Now let's take a look at the solution that they've given here. So they have also done the same steps where they have either used the equation u1 plus 7d and the second equation and solved, so our answer is correct. And you can look at how this was graded over here. Let's move ahead with the next question now. The next question is, the arithmetic sequence has first term as 60 and the common difference is minus 2.5. Then given the kth term of the sequence is 0, find the value of k. So I'm going to use the same formula over here where we have u1 is equal to 60, d is equal to minus 2.5. They have given us that the kth term is 0. So uk is equal to 0. So 0 is equal to u1 plus n minus 1 times d, or I can say k minus 1 times d, which would be minus 2.5. So u1 is 60 minus 2.5 k plus 2.5 is equal to 0. So I can take the 62 to the other side. Minus 62.5 is equal to minus 2.5 k. So k would be equal to, we can use the calculator over here in order to find the answer. So the answer after using the calculator would be, let me quickly do that, 62.5 divided by 2.5. The answer of k is coming out to be 25. So the kth term or the 25th term of this sequence is going to be 0. Now, whenever we have to find the maximum value, first let's look at what the first part of the question helped us get. It helped us find a place, a term where the value of that term is going to be 0. So every term after this would be negative because d is negative 2.5. So the maximum would occur at this k value, which is 25. So what we essentially need to find is S25, and using the sum formula, which is n by 2 times 2u1 plus n minus 1 times d, we can find the value of this. So it would be 25 by 2 times 2u1, which is 2 into 60, so 120, plus n minus 1. N is 25. So 25 minus 1, 24 times negative 2.5 over here. And then let's simplify this. So 25 by 2 times 120 minus 60. So this would be 60 by 230, 30 into 25, which is 750. So this is how we can find the sum of the maximum value, and any terms beyond the 25th term would be negative. So the sum would start reducing. Therefore, this is the maximum sum. Now let's quickly look at the mark scheme. The mark scheme says either we can use the graphing method to figure out, or we can figure out that the maximum occurs at n25, which is what we have done. And this is how we've solved this question. Now let's move ahead to the next question. So the next question is to find the sum of n terms of a geometric sequence is given by Sn is equal to sigma r is equal to 1 to n 2 by 3 times 7 by 8 raised to the power r, and we have to first figure out the u1 term. So the u1 term would not be nothing but the S1 term, which is the sum of 1 terms. According to this sigma notation, it should be 2 by 3 times 7 by 8 raised to the power 1, where we can cancel off the 2 and the 8. So this would be 7 by 12 as the first term. Now, if you look carefully in the sigma notation, every term is getting multiplied by 7 by 8. So the common ratio of this geometric sequence is going to be 7 by 8. Now, the next thing we need to do for the B part is we have to figure out the value of sum of infinite terms. That is given by the formula u1 by 1 minus r. So we have 7 by 12 divided by 1 minus 7 by 8, which would be 7 by 12 divided by 1 by 8. And then we know that 4 would go into this 3 times, 2 times, and then 2 goes on top. So the sum of infinite terms would be 14 by 3. C part is we have to find the least value of n such that S infinity minus Sn is less than 0.001. So we know that S infinity, we calculated it in the B part as 14 by 3. And then Sn is given by the sigma notation, r equal to 1 to n 2 by 3 times 7 by 8 to the power r should be less than 0.001. Now we know that there is a formula for sum of n in finite geometric series, and the formula is given as Sn is equal to u1 into 1 minus r to the power n divided by 1 minus r. So I can write this as 14 by 3 minus u1 is 12 times 1 minus 7 by 8 to the power r, or to the power n, divided by 1 minus 7 by 8. And I can then try to simplify this to get the value of n. So over here I'm going to get 1 by 8 in the denominator, which can then be further simplified as 3 and 2, and this could go on top. So we would get 14 by 3 minus 14 by 3 times minus 7 by 8 to the power n. On expanding this, we would get 14 by 3 minus 14 by 3 plus 14 by 3 into 7 by 8 to the power n should be less than 0.001, and these two terms can get cancelled. Now using the calculator, we can find out the value of n, and the value of n comes out to be 64. So this is how we can do these questions. Now let's take a quick look at the solution. So we did find the first term to be 7 by 12, the common ratio is 7 by 8, and then we found the sum of infinite terms is 14 by 3, and the least value of n is also 64. So if you enjoyed this part of the video, then definitely go look at the links in the description, and please subscribe to my channel Maru Maths for more such videos. And thank you, Ginger Maths, for allowing me to collaborate with you.
Okay, and on to the AI questions, the applications and interpretations questions. And if you're liking the content that Maru Maths and myself are doing here, then do leave a like on the video and think about subscribing to both our channels. That will certainly make us happy. Now you see the formulae in front of you. This comes directly from the AI formula booklet, and these are the formulae I'm going to refer to as we go through these IB questions. So you need to know where these formulae are, and I will refer to them as we go through the questions. Right, let's carry on. So question 6 for 5 marks, an infinite geometric series. I tend to underline these key terms. So infinite and geometric sequence. So this is going to be a high level question with terms un such that u1 is equal to 2. So the first term is equal to 2. And now we've got this strange notation I'm going to explain here. So from k is 1 to infinity, this sum is equal to 10. So what this is saying in real English is u1 plus u2 plus u3 up to infinity. This is equal to 10. So the sum of the infinite series is equal to 10. And from the information given, we need to work out the common ratio R for the sequence. So that's going to be our first question for 2 marks. Now we're going to use the sum of an infinite geometric series. So S infinity, and you'll notice this is on the formula sheet. So this is this formula down here, which we can use. So it's equal to U1 over 1 minus R, where R is the common ratio. So I'm just going to copy that across from the formula sheet. And we've actually got all the information we need here to answer this question. Notice U1 is equal to 2, the first term, and the S infinity, so the sum of all the terms up to infinity, is equal to 10. So we can just substitute this in. So 10 is equal to, because this is equal to 10 here, U1 is 2, so we get 2 over 1 minus R. And at this point, this is just an algebraic exercise to get R on its own. So to do this, the way I would generally go about doing this is multiply by 1 minus R on both sides of the equation. This cancels here, which is the whole point. So we get equals to 2 here, and then we get 10 lots of 1 minus R. Now we could expand the bracket and simplify. I'm going to take a slightly different approach here. I'm going to divide both sides by 10. Notice I'm really just trying to get this, R on its own. This cancels, gives us 1 minus R. 2 divided by 10, that's equal to 0.2. And probably from this point you can see R is equal to 0.8. Again, we can minus 1 from both sides, giving us this, and then timesing through by minus 1, giving us our final answer of R is equal to 0.8, like so. Again, you could always use nsolve to solve at that particular point. Now B, again, is the usual twist they do on these kind of questions. Find the least value of n, so that's going to be important a bit later on, such that the nth term of the sequence, that's what un stands for, is less than a half. Whenever I get these kind of inequality questions, the way I generally approach this is I'm looking for the critical value, i.e. when un is equal to a half, and then work with the inequality later on. I do this for a lot of inequality questions. Now, what is un? So what is the nth term? Back to our formula sheet, which is here. We'll see the nth term of a geometric sequence. Remember, geometric in this question is equal to u1 r to the power of n minus 1. Now we now know r, that's equal to 0.8 from the previous question, and we knew u1 from the question, that's equal to 2. So I'm going to substitute those in. So that means this is equal to 2u1, and then we get 0.8 to the power of n minus 1. If you're wondering where this comes from, I'm literally taking this formula, replacing the u1 with a 2, and replacing the r with a 0.8. And I want to see when it's equal to a half.
Now remember, this is the applications course, which means you always have access to a calculator. And I'm going to show you now on the TI Inspire calculator how I generally solve equations on the calculator. I generally take a graphical approach. So let me show you how that works. Okay, so I've got the graph function open here. So to do this, you go to the home page and we want a new document and we want to go to add graphs. And the way I generally approach these questions is if I go back to the question, I'm going to type in the left-hand side of the equation first of all. So I'm going to type in, oh, that's me. Don't want to see me. 2 open bracket 0.8 to the power of n minus 1. So I'm just going to type that in. I'm just going to type in 2 open brackets 0.8, and you can see the buttons I'm pressing here. And again, the calculator works in terms of x, so we're going to type it in instead x minus 1. That's going to give us a random graph. Don't worry about how it looks so far. It's actually quite a nice graph to look at here. And then if you press the tab button, you can automatically make up a second function. And I'm just going to type in 0.5, so a half. And you see we get a line that goes across. Now if this gets in the way, you can just drag it out of the way as well. You can also zoom in and zoom out with the same kind of function as well. I'm just going to put that over here. And what we're looking for essentially, and again you can drag to change the scale, or you can change the scale using the menu, is we want to find the intersection point. So we go to menu. When you do this a lot, you get very, very quick at doing this. So intersection, click before, click after, and you'll see we get the value that we're looking for, that critical value of 7.21. So I'm going to come back here. So n is equal to 7.21 dot dot dot. Now the key part of the question here is the least value of n such that that happens. This is where students often get confused, so really do pay attention. Because we want the least value of n, notice 7 doesn't answer the question. That's the problem here. So we want to find the next integer value after 7 that does actually fit the condition, which means that we're going to actually take the value of 8. So be very careful here. The actual answer is n is equal to 8. And we round up because we want the least value of n. 7 doesn't work. Notice the precise answer is 7.21. So the next integer that comes along, the next whole number that comes along to answer the question will be n equals 8. Again, you can check the mark scheme. As you can see, if you do put n is 7 down, you only get 2 marks for that question and not 3. Okay, on to the next question here, question 3. I think this is a paper 1 question. So Charlie and Danielle have each begun a fitness program, and on day 1 they both ran 500 meters. On each subsequent day, so the day afterwards, Charlie ran 100 meters more than the previous day. Okay, so that's going to be an arithmetic sequence or series, whereas Daniela increases her distance by 2% each time of the distance ran the previous day. That's going to be geometric. And now we need to find out how far they both run on day 20 of the program. This is all about setting this up very, very carefully here. So let's get started. So I'm going to start with Charlie here. So notice our U1, so the first value is going to be 500. That'll be the same for both of these series. And notice the common difference. So what are we adding on each time? Well, that's going to be equal to 100. And here we're actually looking for U20. Now this is where we can use the formula. So if we go back, we are looking in this point at working out a specific value of sequence, which means we're looking at this formula. So UN, or in this case be U20, is equal to U1 plus 20 minus 1 times the difference. So if we copy this across, we get U1, which is 500, plus 20 minus 1, n minus 1, times 100. So that's going to be equal to 500 plus 19 times 100. And if we work this out, again, we can do this without a calculator. This can be 2,400 meters. So first answer for Charlie, after 20 days, he's now running at 2,400 meters. Not too bad on a fitness program, I have to say. And if we take Daniela here, we just need to be a little bit careful how we set this up. U1 will stay the same. So that's going to stay at 500. And remember, for a geometric series, because we've got a percentage involved here, we need to work out the common ratio. So what are we multiplying by each time to increase by 2%? So if we increase by 2%, That's a very big percentage sign. Then we're actually doing 102% each time. And 102% as a decimal, well, that's equal to 1.02. So that's how I work out my common ratio here, that this is going to be r equals 1.02. At this point, we do exactly what we did in the previous question. We go to our formula sheet to work out U20. So let's have a look at our formula sheet here. We're going to use the one that we did in the previous question. So we're going to use this one here. So if we copy this across, we get 500 multiplied by 1.02, and this is going to be to the power of n minus 1, so that's important, so it's going to be 19. At this point, I can't do this in my head, so let's go to the calculator and work it out. Okay, so we're just going to type this in, so 500, open bracket, 1.02, and we use this button to get to the power of, and we want 19 here. That gives us 728.4, so let's pop that across. 728.4 ... Remember, generally on IB exams you want 3 significant figures, so we want to then do 728 meters. So notice Charlie is doing a lot of fitness after day 20. Daniela not so much, but you can see that changes as we go through the fitness program. Okay, and question B is a little bit more tricky. So on day N of the fitness programs, Daniela runs more than Charlie. That's important for the first time. Remember, they both start at 500, and then we want to see when Daniela is running more than Charlie, and we want to work out the value of N. This is a question that students often find tricky because there's not much guidance on what you do here. Essentially, what we want here is to make the nth term of Charlie's running the same as Daniela's nth term. So how do we do this? We're going to use the two formulae from before. So if we go back, we're going to use this formula first of all. So we're going to have, there we are. So UN, so this is for Charlie, let me put that in brackets. It's going to be equal to U1, so that's equal to 500, plus N minus 1. This time we don't know what N is, that's what we're trying to find. And the difference is 100, so we pop that in. And if we do the same for Daniela, so let me just write that in. Well, that's going to be equal to 500, 1.02, so similar to what we did in part A, to the power of n minus 1. I'm just using those two formulae on the formula sheet. And again, the way I work this out is I'm going to make them equal to each other, so see when they're running at exactly the same amount, and then work out when Daniela actually runs more than Charlie. So the way I do this, I make them equal to each other. You see this technique that happens again and again. So I'm going to take this. Notice I don't even have to simplify here. And pop this in. And again, we're going to use our graphical calculator to work out the solution, and then we can work out that value of n. Remember, we're looking for day n, which we'll talk about after we've got our solution. Okay, so we're going to type both in just like we did before. So we've got 500 plus, again, we have to make sure we use x, otherwise the calculator gets a bit confused. So we type in the first thing. Again, don't worry about the scale in the slightest at this point. If we press the tab button, then we can type in our second function. It doesn't start doing very funky things like this. Okay, let's try again. There we are. So we get 500. Interesting software sometimes. 1.02. And then if we write this to the power of x minus 1, again, we always have to use x. That's really important. And we get another graph that we don't see at the moment. Now, at the moment, we have no idea where they're going to intersect. This is where I use the kind of cheat. So if we go to Zoom, again, you can use this in the exam, of course, Zoom Fit, Zoom Auto on the CG50, and this will help you then actually find the intersection point. Now, the thing to be really careful of here is, here's the intersection point. We just go to Analyze Graph, Intersection, and find it. But notice we already knew this fact already. So after day 1, they both run 500 meters. What we're actually looking for here is when they both run at the same time again. Now, if you can drag, you can zoom out as well. That also works. And we want to work out when they actually meet again. Now, dragging's not working too well here. So I'll just use zoom out instead. And notice if I zoom out enough, you'll notice they actually do meet again. So it's all about knowing how to use your graphical calculator correctly. So we're actually looking for this point when, as you can see, Daniela's running lots and lots and lots after that amount of days. So we go again, same operation, analyze graph, and intersection, click before, click after, and notice we'll actually get 184.2. So that's what we're looking for here. So therefore n is equal to 184.2. But as I underlined here earlier, we're working distinct days. So we don't talk about half a day or a quarter of a day, we talk about distinct days. So again, we need to round upwards because we want to know when Daniela runs more than Charlie. On day 184, Charlie is still running more than Daniela. So this is why we round upwards. This is a really important concept. And so it's going to be after 185 days instead. So just be careful with that very last fact. Okay, so you can check the working I've done. You can see where you pick up all those accuracy marks and method marks as well. Okay, on to the next question. So Roger, he's got a new laptop for himself at a cost of £495, decent price. At the same time, he buys his daughter Chloe, that's very nice of him, a higher specification laptop at a cost of £2,200. That's quite a lot of money. It's anticipated that Roger's laptop will depreciate, so it's going to go down on a regular basis of 10% per year, whereas Chloe's laptop is going to depreciate at a rate of 15% per year. So I'm going to underline those two important bits of information. And the first part is very standard. Estimate the value of Roger's laptop after 5 years. So the way we do this, again, this is actually a geometric sequence problem. Now, how do I know this? Because we got a depreciation and a 10%. So I'm seeing that information, I'm going, aha, geometric sequence. Now, the way we have to work that out is we need to work out the first term of the sequence, if you want to put it that way, which is going to be 495. So that's what we're going to start at U0. And what we want to work out is after 5 years. So the common ratio, if we're dropping by 10% each year, then 100% minus 10% is equal to 90%. And therefore that's going to be, as a decimal, 0.9. So our common ratio is 0.9, and now we just need to put it in to work out that term. So after 5 years, because remember after year 1 it depreciates, so that's really important to realize here. So this is why we're going to do 0.9 to the power of 5. That's important because we're starting from 0 and not 1. So if we put that into the calculator, let's just go and do that now. Okay, so we're going to type that in, 495 times, and the key thing to remember in this question is we're looking to the power of 5, not 4, because we start at the 0th term, if that makes sense. After 1 year, there is some depreciation, and that gives us 292.29. Now, when I do these questions, I generally write down some of the decimals and then round to 3SF afterwards. So this is in pounds, so we're going to go for £292, like so. And then this is a very typical kind of question that we've probably seen before, very similar to the previous one. Roger and Chloe's laptops will have the same value k years after they were purchased. Find the value of k. Now this is all about setting this up correctly. Again, as long as you're consistent, that's the most important thing. So this time we don't actually know what this value here is going to be. We want to find when they're equal to each other. So notice this is very similar to how we did the previous question. So I'm going to take the expression from what we did before for Roger's laptop and make it equal to Chloe's laptop. So Chloe's laptop is 2,200. That's our first, well, the 0th term, I should say. And because we're going down by 15% each year, okay, we're going to be multiplying by 0.85 each year. So we get 0.85 to the power of n. Again, I make those two things equal to each other. Again, in a very similar way to how I did the previous question, we're going to work out what that value of n is. So we're going to type this in. So 495 multiplied by 0.9. Again, make sure we use x as well. I'm not going to worry about scales or anything like that. Okay, so I know it's already in the system. I'm not too worried about where it is at the moment. So we're going to type in this one as well, making sure we type it in correctly. So 2200, yeah, that's it, times 0.85. You can of course use the n-1 formula, you just have to be careful when we work out the final answer. I'm going to try and keep this as straightforward as possible. Again, I can't see that graph either. And now we use our favourite button, the button you need to get used to using, zoom fit. And there we are, we finally get the two graphs. Now again, we can use zoom out or we can drag. I am actually going to drag here instead. Might have been better to actually zoom out instead. But the key thing is finding that intersection point. So there we are, I have managed to find it, which is 26.09. So go back to the question. So n is equal to 26.09. Now notice, because of this in years, they're not looking for a whole value, so you're okay here to just round this to 3 significant figures. I should make this equal to k because k is in the question, so k is equal to 26.1 years. Notice if it was in days, I would round up to 27. Because it's in years, I'm happy to leave this to 3 significant figures. And the last part is comment on the validity. This is sometimes something that comes up on these sequences and series questions of your answer to part B. So basically, what is essentially the problem with the models that we are using? And I think the most straightforward approach here, I mean, there's lots of different answers you can put down here, is that we've just assumed the depreciation is a constant here. That, for example, Roger's laptop always goes down by 10%. You might find after 5-6 years, the depreciation rate falls to say 6% or 5%. So we've assumed that depreciation is constant here, which probably for a laptop or a car or something a bit more technological is not really that realistic. Okay, and you can have a look at the answer here. Notice if you do make the mistake with k-1 rather than k, so out by 1 here, for example, you'll get 1 mark out of 2. But you can check the answers here at your leisure. Right, our last question here. So, a meteorologist models the height of a hot air balloon launched from the ground. The model assumes the balloon travels vertically upwards, that's going to be important a bit later on, and travels 450 meters in the first minute. And due to the decrease in temperature as the balloon rises, the balloon will continually slow down. Okay, interesting. Model suggests that each minute the balloon will travel only 82%. Again, as soon as I see a percentage, I'm thinking geometric. That's how you need to think in the exam, of the distance travelled in the previous minute. So, part A, find how high the balloon will travel in the first 10 minutes after it is launched. Okay, now this is a slightly different question here because we want how high. So we don't want to work out how far they've gone between the 9th and 10th minute. We need to add up how far they go in the first minute, how far they go in the second minute, and so on. That's really important. Now, again, we want to travel only 82% of the distance to the previous, so our common ratio is kind of given here. It's going to be 0.82. And our U1 here is going to be 450. So let's just pop those parts in. And notice we're going to use a different formula here. We're going to use the S10 formula, so the sum of the first 10 minutes. Now, if I go back to the formula sheet, you'll notice it is this formula here. So we want sum, that's what we're looking for, and we want a geometric sequence. So this is what I'm looking for. And now we're going to substitute those values in. Now let me just write it out here, just so you've got it. So to work out S10, it's U1 r to the power of 10 minus 1 over r minus 1, and just substitute these values in. So we've got 450, we've got 0.82, so what you have to check, yep, this is r to the power of n, so I'm just double checking these things as we go through, minus 1 over 0.82 minus 1. And we're just going to pop this now into the calculator. Okay, so you get 450, and now we're going to put in brackets again, 0.82 bracket to the power of 10 minus 1 over 0, 8, 2, 1. And then we press the big button and we get 2156.37. Just pop that across. Again, always like to show I've worked this out on the calculator, and only after that do we round to 3 significant figures. So notice first significant figure, second significant figure, third significant figure. Draw a line between the 5 and 6. 6 is greater than 5, so we round the 5 up to 6. And remember to put in our placeholder here as a 0. So a quick bit of rounding practice as well for you, and that's going to be in meters to 3 SF. Making sure I gain all 3 marks for that kind of question. Now this one is going to be a slightly different way round here. So the balloon is required to reach a height of at least, that's important, 2,520 meters. Determine whether it will reach this height. So essentially we take the formula we've done here. So we want the sum to infinity formula because we're assuming an infinite amount of time. Will it ever reach 2,520 meters? Now if you remember the S infinity formula, sum to infinity formula from before, this is equal to U1 over 1 minus R. That is on your formula sheet. And what we want to show here is this actually equal to or more than 2,520 meters? So if I type this in, this is 450 over 1 minus 0.82. So let's go to the calculator. Let's see if it's more than 2,520 meters. Okay, let's type this in. So we have 450 over 1 minus 0.82. And we get 2,500. So let's pop that in. So, oh, that's weird. 2,500. Now this is less than 2,520, so it's won't reach that. Won't reach the height. So I'm going to put in just a sentence there just to make it nice and clear, like so. And lastly, I did underline this earlier in the question, suggest a limitation of the given model. Now notice we assumed right at the beginning that it's going vertically upwards, but we know this of course with hot air balloons that there's going to be some horizontal effect as well, and that's not going to stay consistent. So the wind is going to increase and decrease, so it's not always going to have that same horizontal effect. So what I'd write down here is the effect of the wind going horizontally is not consistent, and therefore is a slight limitation of this model. Okay, you can see there's lots of other reasons why the model is not completely accurate. You really do need to think of this on the AI course and make sure you're thinking about the maths that you're doing. Okay, what application does that have to real life? What are the strengths, what are the weaknesses of the models that we use? If you've liked this section of the video, then please do give it a like. That really helps the algorithm know this content is needed out there and makes me happy at the same time.